This video lecture is meant to give you an introduction to what an orbital diagram is and what an electron configuration is. If you consult your periodic table, you're going to find element symbol boxes that look like this one in front of you. We know a couple things. We know that this number 18 right here represents the atomic number, which is the number of protons in the nucleus. We know that this number up here is the atomic mass, which is the weighted average of all the isotopes of this particular element, argon. And then we have this number down here, which represents the electron configuration. Okay, this is going to give you some very simplified information about where we can find the electrons in this particular element. So the 2-8-8 means, let me rewrite this here, that there are 2 electrons in the first and lowest energy level. The second number tells you that there are 8 electrons in the second energy level. This third number, of course, I'm guessing you're already guessing that this means that there are 8 electrons in the third energy level. Okay. But this is pretty simplified information, but it's a good basis to get us started to talk about where those electrons are, Because remember what I told you at the beginning of this unit, or maybe I didn't, but this unit is all about where the electrons are. We're trying to describe in great detail where the electrons are in atoms. All right, and you're going to kind of forget that, or it's likely that you'll forget that that's what we're really trying to do, because it starts to get really weird looking. Okay. Orbital diagrams is more of a visual way to describe the location of the electrons in an atom, right? So we're talking about argon, which was the 2-8-8. So there's 2 electrons in the first energy level, 8 in the second, and another 8 in the third energy level. Okay. So principal energy levels, there are actually 7 total principal energy levels. There's 7 total. Okay. In argon, there are only 3 that are occupied by electrons. So the first principal energy level, the second principal energy level, and the third principal energy level. But because atoms can get really big with lots and lots of electrons, there are a maximum of 7 total principal energy levels possible for elements. Okay. Where you're going to look for that is you're going to look for the big number. All right, sort of the coefficient. So right here, right, this 7 here tells you that that is the 7th principal energy level. This number right here is the first principal energy level, and so on and so forth. So you can see that the principal energy levels start to get a little bit more specific. We'll talk about that in just a second. Sub-level energy levels are, you'll know you're looking at a sub-level because you'll see a letter. Okay, so the letters represent the sub-levels. The sub-levels that are found within the principal energy levels. They are denoted as S, P, D, and F. There are only 4 total sub-levels that are known at this point in time. Even though there are 7 principal energy levels, there are only 4 sub-levels where we can find electrons. Orbitals are the place where the electrons actually exist. This is where the electrons actually exist. And in an orbital diagram, an orbital is a box. Okay? So all these boxes, all these single boxes that you see represent a single atomic orbital, a single orbital where we can find electrons. Electrons in this diagram are represented by arrows. Okay? So every arrow you see represents a single electron. Now you might be noticing that in any given box, in any given orbital, you can only have 2 electrons per box or per orbital. So that's one thing you might notice. The other thing you might notice is that the arrows have to be pointing opposite directions in a box. So arrows point opposite in any given box. One has to be up and one has to be down, and you'll get greater explanation of that as we move through this unit. So to show you this 2, 8, and 8, where those are, there's 2 electrons in the first principal energy level. That's right here, because this is the only place where we see the number 1 right here. So the 1, 2, those are the 2 electrons that are found in principal energy level 1. Principal energy level 2 has 8 total electrons. Here's where they are. 1, 2, 3, 4, 5, 6, 7, 8. Right? Both in the second principal energy level. Then we see there are 8 total electrons in the third principal energy level, and there they are. So 1, 2, 3, 4, 5, 6, 7, 8, denoted by the 3. Okay? So that's just to give you the idea of making the connection from what you see on your periodic table, this configuration, to how it gets distributed through an orbital diagram. And you're going to get lots of practice with that coming up. All right, so let's take a look at this next diagram. Electron configuration is a code or shorthand to describe the location of electrons in an atom, because, let's face it, doing an orbital diagram is not entirely practical all of the time. All right, so this is just an electron configuration is just a way to kind of condense the information that you saw in that orbital diagram. So we're continuing to look at argon, right? And we said argon was 2-8-8. Principal energy levels, we said they are the big numbers, right? So that's right there, principal energy level 1. There's principal energy level 2. And there's principal energy level 3. Okay. There are 7 max principal energy levels. Don't have to fill them all, but 7 is the total number that, the maximum total number that any atom or element can have. All right. Let's see. These sub-level energy levels, this is the letters that we mentioned a moment ago. So the sub-level, right? So the first principal energy level only seems to have an S sub-level. The second principal energy level has an S and a P sub-level. And the third energy level right here is showing an S and a P. You're going to find out that the third energy level can actually have a third sub-level that we're going to call D, but you'll see that coming up. Okay. If you wanted to count the number of electrons, all you need to do is add the superscripts. Okay. So, for example, if you add up 6 plus 2 plus 6 plus 2 plus 2, that equals 18 electrons. Which makes sense because argon has 18 protons, which are positively charged particles in the nucleus, and that needs to be balanced out charge-wise with 18 electrons, which are negative, and of course zooming around the outside of the atom. All right, let's see, what else do we need to make sure? You need to know. All right, well, hopefully this gives you at least a basic understanding of what it is you are looking for. I suppose I should just mention that when I talk about the shorthand configuration, or if I mention the noble gas shorthand configuration, what you'll see is, for example, you'll see something like this. Argon would start out with everything that neon has, plus the 3s2, 3p6, right? And you will learn more about that. But when I talk about the noble gas shorthand, that's what I am referring to. The full electron configuration is this. When you write everything out, you don't condense it, you don't abbreviate it in any way possible. And then there is the periodic table shorthand, which was the 2-8-8. So that's what you get directly off of the periodic table. All right, hopefully this gives you a good start to get you going on understanding the very complex, crazy topic of electron configurations and orbital diagrams.